Imagine staring at a speck of light in the night sky, knowing that hidden around it is a world that could rewrite everything we know about life in the universe. What if I told you that a planet, just 120 light-years away, might be teeming with alien biology? Not little green men or sprawling cities, but something whispering through its atmosphere, gases that scream life in ways we've never seen before. Buckle up, because this isn't sci-fi. It's the story of K2-18b, an ocean world that's got scientists buzzing and could change how we see our place in the cosmos. But hold on, could this signal be real, or is it just a cosmic tease? Let's dive in and find out, step by step, why this distant dot might be the key to unlocking the universe's biggest secret. First off, picture this: a tiny star in the constellation Leo, so faint you can't spot it without a powerful telescope. Orbiting it is K2-18b, a planet that's not like anything in our solar system. What makes it so special? It's an ocean world shrouded in hydrogen, with an atmosphere that's dropped hints of life stronger than any we've detected before. Discovered back in 2015 by NASA's Kepler telescope during its K2 mission, that's where the name comes from. This world has been under the microscope ever since. But it wasn't until the James Webb Space Telescope, JWST, turned its gaze that things got explosive. JWST revealed a 99.7% probability that the gases we're seeing come from living processes. Yeah, you heard that right. Almost certain, based on the data. But why such a high number, and how did we get there? Stick around, because the devil's in the details and it might just blow your mind. Let's start with the basics. Where exactly is this intriguing world hiding? K2-18b sits 120 light-years from Earth, a cosmic stone's throw in galactic terms, close enough for our tech to probe it deeply. That distance means light from there takes 120 years to reach us, so we're peering into its past. The star it orbits, K2-18, is a red dwarf, cooler and smaller than our Sun, tucked in Leo, which you can spot rising in the east during Northern Hemisphere spring. But don't grab your backyard telescope. This star is magnitude 13, about 16,000 times dimmer than the faintest naked-eye stars. No wonder we needed space observatories to uncover its secrets. Why does its location matter? Because red dwarfs are the galaxy's most common stars, making up 75% of them all. If life thrives here, it could mean billions of similar worlds are out there, waiting to be found. But what keeps drawing us back? The planet's spot in the habitable zone, the Goldilocks region where water can stay liquid. Too close, and it boils. Too far, it freezes. K2-18b nails it, orbiting every 33 days, bathing in just enough stellar warmth. Now, what kind of planet are we dealing with? K2-18b isn't a rocky ball like Earth or a gas behemoth like Jupiter. It's a super-Earth or mini-Neptune, 2.6 times Earth's radius and 8.6 times its mass. Think of Earth as a marble, and this as a hefty melon. Stronger gravity, thicker atmosphere, no solid land in sight. Experts call it a Hycean world, a mashup of hydrogen and ocean. Why Hycean? Models suggest a vast global ocean under a hydrogen-dominated sky, conditions we once thought hostile but now see as prime for life. How do we know? Infrared data from JWST shows water vapor, methane, carbon dioxide, and that tantalizing hint of dimethyl sulfide, DMS, a gas Earth's oceans produce almost exclusively from living plankton. If confirmed, this could flip our understanding. Life not needing oxygen-rich air, but thriving in hydrogen soups like Earth's deep-sea extremophils. But is this ocean real? Density clues point to layers, a core, deep water, and gaseous envelope. Imagine alien seas hundreds of kilometers deep, where pressure turns water into exotic states like supercritical fluid, neither liquid nor gas. Wild, right? And if it's tidally locked, one side eternal day, the other night, atmospheric winds might swirl heat around, keeping things balanced. Tease, could life hide in those depths, invisible to us? Speaking of discoveries, how did JWST pull this off? Launched in December 2021 and operational by mid-2022, this infrared powerhouse peers through cosmic dust like no other. When K2-18b transits its star, passing in front, dimming the light, starlight filters through the planet's atmosphere, imprinting chemical fingerprints. That's transit spectroscopy. Not photos, but spectral lines revealing gases. Hubble spotted water vapor hints in 2019, but JWST cranked it up, confirming vapor adding methane and CO2 and spotting that DMS bombshell. Why DMS? On Earth, it's 99% biological, no known non-living source in abundance. Here, in a habitable zone, unprecedented. But skeptics ask, could exotic chemistry mimic it? JWST's precision, ruling out ammonia, boosting disequilibrium signals, pushes the odds to 99.7% for biology. Yet, this came from targeted observations, not luck. K2-18b was a top pick, large atmosphere, dim star for contrast. More transits planned, each sharpening the picture. What if the signal strengthens or fades? That's the thrill, science on the edge. Curious yet? Let's zoom in on those gases. Water vapor, the first breath of habitability. Confirmed by JWST, it suggests clouds, maybe a water cycle, evaporation, rain, oceans below. Why big? Essential for life as we know it, regulating climate, enabling chemistry. Models peg temperatures at 0 to 30 degrees Celsius, 32, 86 degrees Celsius, perfect for liquid water under high pressure. But K2-18b's no Earth twin, hydrogen heavy, possibly no solid surface, just endless sea under puffy skies. Then methane and CO2. Together with water, they hint at disequilibrium, gases that shouldn't coexist without constant refresh, often biological. And DMS, the shocker. Formula CH3.2s, sulfur-based, Earth's phytoplankton pump it out, seeding clouds, shaping weather. No abiotic path matches JWST's levels in hydrogen air. If real, it's life's fingerprint. But why here? Hydrogen boosts signals, puffier atmosphere, clearer traces. Life might mimic Earth's hydrogen-munching microbes in vents, feeding on CO2, releasing methane DMS in darkness. Teaser, what if this trio vanishes next observation, or grows stronger? That 99.7% stat, not hype, Bayesian modeling. How? Scientists simulate millions of atmospheres, abiotic, geology, photochemistry, versus biotic, life-produced gases. Data fits biotic 99.7% better, but it's probability, not certainty, based on assumptions, noise margins. 3 sigma confidence, exciting but needs 5 for discovery. Why debate? Models Earth-centric, alien chemistry could fool us, future data will test. Meanwhile, hydrogen atmospheres, once dismissed as unlivable, now promising. Why puffy for detection, insulating for stability? Earth microbes thrive in hydrogen vents. K2-18b could amplify that. Evolution under such skies. Primitive, chemical-fed, resilient. Red dwarf challenges, flares. K2-18's quiet, but radiation could strip air. Yet K2-18b holds its envelope. Thick atmosphere shields, water absorbs UV. Flares might even spark prebiotic chemistry, stirring life's pot. Gravity, density, stronger pull, 1.3, 1.5x Earths, compresses interiors, exotic water phases. Core heats via decay, tides, circulating nutrients. Tidally locked, models show hydrogen redistributes heat, maintaining liquid water globally. Trio signature, CH4, CO2, DMS in imbalance, needs replenishment, likely biology. Rare outside Earth, DMS biotic only here. Comparisons? Unlike Earth-likes, Proxima b Kepler 452b, thinner signals, volatile stars. K2-18b's puffiness aids detection, stability, DMS rarity. No solar system finds, fragile without life. Modeling, radiative transfer simulates skies, Bayesian ranks hypotheses. DMS fits best, but degeneracy risks. False signal, possible. Noise, confusion. Upcoming transits, 2026 plus crucial. Future, more JWST. Labs simulate atmospheres. Life produces DMS abundantly. Abiotic doesn't. Turning point challenges Earth bias, Hyceans common, 2 to 3 Earth radii frequent. If one has life, billions might. Bio vanishes, refined search, no loss. If life signal to Earth, 120 years. Techno signatures, radio scans ongoing, frequencies, beams tricky. Direct image, JWST no, but LUVOIR HABEX 2030s+, could. Magnetic field? Likely, shielding air. Evolution, older system, 6 to 8 B years, more time for complexity. Subsurface, like Europa, hidden vents thriving, clouds, hazes, pale skies, perpetual twilight, megastorms if locked. Escape, stable envelope, gravity holds. Comparisons, TRAPPIST-1 volatile, TY700D data poor, K2-18b wins detectability. Metallicity, low favors Hyceans, alien biochem. Seasons, axial tilt unknown but spectral shifts could reveal cycles. Turning point, first biocandidate in habitable zone, redefines habitability, spurs surveys. Hyceans everywhere. Galaxy teams, Earth not norm. What if K2-18b is just the start? Imagine the universe alive, waiting. The hunt's on, stay curious. The discovery of K2-18b could be the moment we realize we're not alone. Say a world 120 light years away, wrapped in clouds and oceans, whispering chemical hints of life. If confirmed, it would change everything we know about biology, evolution, and our place in the cosmos. But is it truly alive, or just a cosmic illusion? The answers are still coming, and the next JWST data could rewrite history. What do you think? Are we standing on the edge of the greatest discovery ever? Share your thoughts below, and don't forget to like, subscribe, and stay curious as we explore the universe together.